What happens when the surface is not level? There will still be a normal force, and it will still be perpendicular to the surface. Here we see a skier heading down an incline. There is an orientation key, like a compass rose, on the left side of the skier. Here it denotes the inclined x and y axis. I usually use the parallel and perpendicular notation instead. Remember that an opposite down capital T indicates a line or plane is perpendicular, and two vertical straight lines indicate lines or planes that are parallel. Either way is correct, and you should be able to interpret either notation. Again, in this example, your textbook uses x and y. Notice that the force of gravity, or weight, is still directed straight down toward the earth. The skier may be moving downhill, but in terms of the motion perpendicular to the plane, the skier is not plunging through the surface of the earth. That means the perpendicular component, or y component, of the skier's weight is equal and opposite to the normal force exerted by the ground onto the skier. The parallel component of the weight, the x component, is the force that's pulling the skier down the hill. In next week's module, we'll learn how to model frictional force on our free body diagrams. In this image, there is a frictional force acting in the direction opposite to the downward motion. For these inclined plane problems, then, after you create your initial free body diagram, you need to break the weight vector down into its perpendicular and parallel components.